Number 2. What should we do first?
Multiplication.
Multiplication. Like make them common denominators?
The fraction.
Yeah, we could do common denominators, but that's not the quickest way. The quickest way is to do what?
Make them into more numbers.
How did you do that?
10 goes on to 5 2 times. That makes the 1 that's 2. And then 3 goes on to 3 1 time.
So we get 2 minus 1, which equals?
1.
So that's the answer for 2. Now we're going to go ahead and look at number 4. What do you do first in 4?
You multiply the 3 times.
Mm-hmm. So we multiply those two together, okay? So what is negative 3 times 3?
Negative 9.
Mm-hmm. So we have 5 plus 2 minus 9 minus 1. What does we do from there?
Just do it like a normal.
Left or right?
So 5 plus 2 is?
7.
Minus 9 is?
2.
Negative 2.
Negative 2. Negative 2 minus 1 is?
Negative 3.
There we go. All right. Now we're going to look at 16. What should we do first in, or not, why do I keep calling this problem 16? What do we do first in 6?
The first parenthesis.
Okay. What is 17 minus 3?
14.
So we have 14 divided by, what can I do with that second parentheses?
Subtract 5 from 4.
Which gives us?
1.
So we have 1 times 4. So we have 14 divided by 1 times 4. What order do I need to do that in? What was that? Left to right. All right. So if we look at this, what should my answer be? 56. Because 14 divided by 1 is?
14.
And then 14 times 4 is 56. All right. So we're going to go ahead and flip to the next page. All right. We're going to look at algebraic expressions real quick. So what is the difference between an expression and an equation? You remember? What's the difference? Expression has no equal sign. So we're just going to look at simplifying some expressions. We're not going to throw in the equal sign until Monday. So algebraic expression is a mathematical phrase made up of numbers and variables. All right, so we have an expression here. We have 7x plus 3 minus 5x plus 8 plus 4x minus 1. And we're going to talk about the parts of that. Within that, we have both variables, we have coefficients, and we have constant term. And we're going to talk about what makes it what. So first off, let's start with constant. What is a constant? It's just... Yeah, what is a constant number that we would think about in this context? Which of those are constants? What are the constant terms?
3.
3, what else?
8.
And? 3, 8, and negative 1. And we know they're a constant term because they do not have a variable with them. Okay? Now, our variable terms are just that. They are terms with our variable. What is the variable in this problem?
X.
So what are our variable terms?
7x, 5x, 4.
7x, negative 5x, and 4x. Now, a coefficient is the number where? In front of the variable. So what are our coefficients?
7, negative 5, and 4.
There we go. Now, we are going to look at combining like terms. Okay? So in order for us to simplify an expression, we have to combine like terms. So that just means we are going to combine terms with the same variable and constant terms. So we're going to simplify that expression we've already looked at. So we said what was our variable terms? And are those 3 variable terms like terms? Yes. So if we combine those, what is 7x minus 5x?
2x.
What is 2x plus 4x?
6x.
All right, then what is our constant terms that we can combine?
3A and 1.
So what is 3 plus 8?
11.
What is 11 minus 1?
10.
So we get 6x plus 10 if we combine those. All right, so we're going to go with the odd questions here. So for number 1, okay, what is our like terms in number 1?
3x and 6x.
Which gives us, all right, for 3, what is our like terms?
6x. Or, yeah, 9.
9 and 5 are like terms. What is 9 plus 5?
There, 14.
And then does negative 6x have any like terms?
No.
No. Now, is this the order that's like the right math way to write it?
No.
How should I write that?
6A minus 14.
Negative 6x plus 14. Whatever our sign is in front of it will stay in front, even if you move it. All right, for number 5. Does 5x have any like terms?
3x. And x.
And x. So what is 5x minus x?
4x.
Plus 3x?
7.
So we have 7x. And then does 7y have any like terms?
No.
And then is there any constant term?
27.
It's just 27. All right, so that would be our answer. Now I want y'all to do the evens for me. Combine the like terms of the 3 even problems there. All right, what is our answer for 2?
1.
Negative.
Negative 1a. Or you can just say negative a. Either's fine with me. I will never fault you for showing a coefficient of 1. It is not necessary, but I'm never going to fault you for that. If you need to do it, put it there to make sure it makes sense in your brain, put it there. It's not going to hurt anything. Now, for number 4.
10. Negative 4 plus 10p.
So which way should I write it to be right on the math way?
10p minus 4.
10p. So we got that combining those two, and then we have minus 4 from negative 7 plus 3. If you wrote it the other way, you're not technically wrong. It's just we tip in math, the right way to write it is variable first. Yes?
Would you take off points if we did that?
As of right now, no, because we haven't had a formal discussion about it now. But if we have that formal discussion, then yeah. And if the whole point of the problem says write it in standard form, then that would be, you have to write it a specific way. But if I'm just asking you to simplify it, not really. All right, for 6, okay?
17a plus 10b minus 3.
So 17a plus what?
10b minus 3.
Because we combined 15a and 2a, 6b, 4b, and negative 3. All right, we are good to look at the back of this page. Or the next page. I don't really know how the layout is of that. Because mine is not front and back. All right, now, we can also look when we have terms with exponents, okay? So if your terms have the same exponents, or combination of variables and exponents, they are considered like terms. And when we combine them, so that means when we add and subtract terms with exponents, we do not change the exponents, okay? The only time exponents get changed is if we're multiplying or dividing, not when we're adding and subtracting. All right, so let's go ahead and look at, let's just keep with the trend and do odds. So for 7, what is our like terms there? Are 5x squared and 7x squared like terms? They are, because they not only have the same variable, but they also have the same exponent. So what is 5x squared plus 7x squared? All right, for number 9, what is our like terms?
7x squared and 3x squared.
7x squared and negative 3x squared. What is that going to give us if we combine it?
4x squared.
All right, what about, what's next? What do I do now?
Plus 4x.
Plus 4x. All right, for number 11, does a squared have any like terms? So bring it down. Okay, does 7ab have any like terms?
Yeah. Negative 10ab.
And what is 7ab minus 10ab?
Negative 3ab.
And then we have plus b squared. All right, so now y'all do those 3 evens for me. All right, for 8, what is the answer for 8?
Negative 10n cubed.
Negative 10n to the 3rd power. Or negative 10n cubed, either way is fine. All right, for 10, what is our like terms?
6k squared and 8k squared and negative 2k squared.
Which does give us 6k squared. Does negative k have any like terms?
No.
What about positive 7?
No.
All right, for number 12, does 4x squared have any like terms?
Yeah.
What?
Negative 3x squared.
Which combined gives us?
1x squared.
And do I have to write the 1 in front?
No.
All right, what goes next?
X. 2x plus 8x.
Which is?
10x.
Then last, what do we need to put?
Negative 7 minus negative,
Which is?
negative 13.
There we go. All right, we are also going to talk today about substitution. What does substitution mean?
You're switching something out for another.
So if we are looking at the substitution property, it is if A equals B, then A may be replaced by B in any expression. Basically, if A equals 2, then you can replace A with 2. That's all that means. All right, now, when we are evaluating an expression with variable replacement using substitution, okay, the first thing we have to do is we have to substitute the variable with their given values. Each time we substitute a variable, we need to put what around the number? When we plug something in, what do we need to put around the number we plug in? Parentheses. And then to evaluate it, we just follow the order of operations. So I want us to go ahead and look at number 13. So for number 13, okay, we are going to plug in what for A? And then for B, what do we need to plug in?
4.
And then when we plug in for B, the square will stay outside the parentheses. And then we have plus C, but instead of C, we should plug in. So by every time you substitute a value in, you put a parentheses around it, you are going to lessen the likelihood of you making little bitty tiny mistakes by just incorrectly putting signs somewhere or something like that. If you write down the exact thing you started with, but just instead of the variables with parentheses, it will make your life a little bit smoother of a process if you're doing a bigger problem, okay? And it will also lessen the likelihood of you making little tiny mistakes. Now, what do we do first for order of operations here? Exponent first. So what is 4 squared? 16. So we're going to have 2 times 16 plus 7. What is 2 times 16?
32.
Then we have 32 plus 7. What is 32 plus 7?
39.
So that right there is our answer.
You said 38.
Oh, yeah, no, I said.
All right, now we're going to look at 15. Same thing. So instead of A, we're going to put our parentheses. So A squared times B minus B squared. So what do I need to substitute in for A? And what do I need to substitute in for B?
-4.
And what should I do first here? Exponents. What is 3 squared? So we have 9 times -4 minus, then we have -4 squared. When we square something, what are we doing?
Multiplying it by itself.
So what is -4 times -4? Positive 16.
Yeah.
Okay. So what is 9 times -4?
-36.
So -36 minus 16 will give us what number?
20.
Hmm?
Oh, wait, negative 20.
Is it going to be though, or 'cause we're taking -36 and then we're taking it further -16?
52.
-52. All right, let's go ahead and flip to the back. We'll flip to the next page. I don't know how the layout is. All right, now we are going to go ahead and we are going to do 17 and 19 together, and then I'm going to let you do 17 and 20 on your own. Or 18 and 20 on your own. Good gracious, if I can make it make sense. So we're going to start with 17. So for 17, we have a negative y squared minus 3 times x times y. What can I plug in for y?
2.
And what do I plug in for x? Okay, so what should I do first here?
The exponent.
So 2 squared is 4. Does this negative get squared?
No.
No, it doesn't. it stays outside, so we're going to do negative 4. Now, we can multiply 3 things and do it down the road, but since one of those is a fraction, what should I do to write out so that it makes it easier to multiply all 3 of them? What makes it easier to multiply a whole number with a fraction?
Make it a decimal.
No,
Make it a fraction.
make it also a fraction. So we just put these both over 1, and then we can just go straight across. So what is 3 times 2?
6.
So what is 6 times 2?
12.
So we have minus. What is 1 times 3?
3.
What is 3 times 1? 3. Now, what is negative 12 divided by 3?
4.
So we have negative 4 minus 4, which is negative 8. And it's not 0 because both of them are negative, and so we're saying negative 4, take away 4 more. All right, now for number 19, let's do this one. We have a squared plus b squared divided by a minus b. All right, so for this one here, what should I plug in for a? What should I plug in for b? What do I do first? Okay, so negative 3 squared is what?
Wait, no, positive.
Positive 9. Okay, what about 4 squared? What's that?
68.
Okay, and then is there anything I can do in the denominator? And I can go ahead and subtract it. There's no exponents or anything down there. So what about negative 3 minus 4? Negative 7. So now our numerator. Remember, numerator is the top of the fraction. What is our numerator going to be?
25.
25 divided by negative 7. Is there anything I can do to simplify that? So that's our answer. All right, I want you all to do 17 or 18 and 20 for me, please. They are the exact same setup, just different numbers. when we set up 18. Okay, what do I plug in for y?
Negative 3.
Mm-hmm. And what do I plug in for x?
Negative 4.
All right, so we set that up. What do I do first?
X squared.
So we get 3 squared, which is,
9.
so what should I put first?
The minus.
Mm-hmm. Negative 9. Then we multiply over here. What is negative 3 times negative 4?
Negative, or positive.
Yep, positive 12 times 3 is,
36.
what is negative 9 plus 36?
27.
Yeah, that's right. All right, then for 20. What do I plug in for A?
3.
What do I plug in for B?
Negative 5.
So our numerator, what should I do first? Exponents. What is 3 squared?
9.
What is negative 5 squared? Then in our denominator, I am subtracting a negative number. So what does that mean happens? A negative and a negative. So what is 3 plus 5? Okay, so now our numerator is going to equal what? What is 9 plus 25?
34. Yeah.
30.
Now, can I simplify 34 over 8? How? What can go into both 34 and 8? 2. So 34 divided by 2 is
17.
8 divided by 2 is
4.
4. All right, and then we are going to wrap up there today.